This is video number 12 in the series of tutorials for building our Drive app. This is also the beginning of stage 5. It's the first one in stage 5. So I have the written guide for stage 5 open in front of me. The setup is very similar to previous stages. We start from where we left off on stage 4. I already downloaded or unzipped the teacher pack for stage 5, and it's already here in my assets. And we're going to duplicate the scene Drive Stage 5 and call it Drive Stage 4 and call it Drive Stage 5 and open it. So, scenes Drive Stage 4, edit, duplicate. It's now called Drive Stage 5. I'm going to double click to make sure that's the one I'm editing. One more thing, which I pointed out by the end of stage 4, but I'm going to point out again. Because we have post effects on the camera, what might happen is that we will see those post effects in the scene window, even when they're not on the camera, because what we're looking through is not the camera. So what it might look like is under here, which is like, toggle, what you want to see or don't want to see. If your post-processing is on, it might look like the scene window is underwater all the time. So you could just pull down this menu and ask not to see the post-processing. In any case, this is not going to affect the way it looks to the user or the way it's going to be built in the Quest. And that's exactly what it says in the guide. You might see the color filter. If it bothers you, that's how you turn it off. And we're ready to start the real steps. So this stage is about mainly two things. It's about adding sound to the vehicle, both like engine sound and impact sound, and completing our track, at least the shape of the track. So the first thing we're going to do is create a new empty object, which is going to be called vehicle sound. And even though it's not going to have any visuals, we're going to reset its transform. So this is just an object just for the sound. We're going to add an audio source to it. And as it says in the guide, we're going to give it an resource called Buzz3, which came with a teacher's pack. We're going to check Play on Awake and loop. This is a little unusual. This sound is not going to wait for anything to play. It's going to always play. What we're going to control about this sound is its volume and its pitch. So, vehicle sound, the resource is going to be called Buzz3, which is a pretty annoying sound. And we're going to not only make sure it's Play on Awake, but loop. That means that if we play right now, it's going to be extremely annoying because it's just going to play forever. It's not going to be a lot of fun to play this game. But what we're going to do now is control this sound by going to that object called vehicle sound. We're going to add a script which is going to be called sound controller. Make sure it's the exact name, capital S, capital C, and it's going to be in the My Scripts folder. And we're going to replace, it's a very short script, we're going to replace the default content with what it says in the screenshot. So I already have or should have that is it sound controller? Yeah. Let's make sure. Sound controller, here it is. So here's my script. I'm going to make sure that it's attached to vehicle sound. I could have created it already by, add component. And I'm going to open it so we can see. I'm assuming that, if you are continuing the video, that means that you already paused, typed the code, and are ready to hear the explanation of how the code works. Waiting for it to open right now. Here it is. It's a relatively short script, and it's not only short, parts of it are a comment. So Again, remember, this script belongs to the object that has the sound, the audio source. So, the only using is the Unity engine. The public class is called sound controller, just like the name of the file. And it has only one variable, a public variable called audio source. In other words, asking whose sound am I controlling? And we're going to populate this, of course, with the audio source of this very object. And then on update, look at this. On update, which means 72 times a second over and over and over again, it's going to take this audio source, then, first of all, figure out math float.abs. Abs is for absolute, which means it's going to ignore positive or negative. I want the same control whether the car is going forward or backward, whether the forward velocity is a positive number or a negative number, just like an engine of a car. The engine of a car still makes sound when you're going in reverse. It's going to go to that variable that we have measured or reported with the front wheel or the wheel spinner. The wheel spinner is the one that is checking or it's reporting the current z velocity. The current velocity of going on the z-axis, whether it's forward or backwards. And we're going to use this number in or this piece of data in this script by taking the application data current velocity, and which is like the speed forward, and we're dividing it by 20. Why are we dividing it by 20? Because by experimenting, and you can see the leftover from experimenting, I found that the common speed of the car, like, you know, when it's going like really fast, approaches the high teens, sometimes 20. So I said something like this: if I want the volume of the sound to range from 0 to 1, I'll have to divide the speed by 20. So instead of, you know, the speed ranging from 0 to 20, the volume will range from 0 to 1. In other words, a factor of dividing it by 20. And this was done only with, you know, from experimentation. The same thing will happen for the pitch of the sound. The pitch is basically the, you know, the speed of the sound. Taking math absolute value, it's always going to be positive, of the current z velocity divided by 20. But in this case, I gave it a bump, like a factor, like a help, like a crutch of 0.3 because I wanted to be the speed divided by the expected maximum speed, like the speed divided by 20, but never lower than 0.3. I don't want it to be total, I don't want it to ever, the pitch to reach total 0. So, how do we know that it works? We go back here, and just like the guide says, the one thing we need to do is populate the public field with the vehicle sound. So in other words, the vehicle sound has a script and it's asking, where's my car sound? You are your own car sound. I'm dragging this. And of course, it knows that it's going to pay attention to its own audio source. From this point on, as I start playing, look at the volume and look at the pitch. When the car is totally at rest, the pitch is 0, and the volume is 0, and the pitch is 0.3, and I cannot hear it. But as I start driving the car, both of those start rising. Look at these sliders. And when the car is at rest, the sound is still playing, only it's playing at 0 volume, so it seems like it stopped. So it gives you a very interactive feeling of sound, of tying both the volume and the pitch to the speed of the car. Just in case you're not really understanding what's the difference between volume and pitch, I'm going to go to the script and comment out the line about pitch so you can hear what it would sound like if we controlled only the volume. It would not be exactly the same. It would not be as good. If we were controlling only the volume, it would sound something like this. The volume goes up and down, but it stays the same pitch. So by controlling both volume and sound, we're achieving a much more realistic illusion of the sound of an engine. The sound of an engine of a car, when we rev up the engine, goes up in volume, but also the RPM goes up, the pitch goes up. I'm also going to, just to show you the process, release that print, which, this is how I arrived at that 20. And I said something like this: let me see how fast this car is moving. I'm playing. I'm going to go to the console. You see how it's like, every frame right now it's reporting a speed. So I'm going to clear and make sure that it's collapsed so it shows only one line. And right now the speed is 0. And I said, when I go really fast, how much, does this number go up? See, it's like approaching the teens here. And I said something like this: since it seems to never be more than the teens, or maybe if I'm really, really, really fast, the high teens, if I divide it by 20, I'll get a scale that's more or less between 0 and 1. Of course, I can play around with this factor. If I divide the number by a bigger number, I will have what's called a dynamic range. If I divide it by a smaller number, it'll be less sensitive. It just seemed that divided by 20 is just the right factor. It's like the expected maximum speed. It's my way of getting maximum speed to be on a scale of 0 to 1, because volume is always between 0 and 1. As you can see, volume is always between 0 and 1. Continuing with the guide, so now we got the car to make a nice sound, and we just achieved step number 5. We test the vehicle volume and pitch, should be tied to the Z. Let me make sure I'm commenting out the print line again. And the faster the vehicle goes, the louder and higher the pitch gets. In the script, you can experiment with the numbers divided by 20 in lines 10 and 11. The bigger the number, the more subtle. The smaller the number, the more loud and consistent. Now let's add an impact sound when the car lands hard on a surface, like when we first start the game or when we jump off of a ramp. We're going to create another empty game object, which is in charge of its own sound. It's called impact sound. So back here, and just like there's a object for vehicle sound, there's going to be a separate object, an empty game object for impact sound, and of course also reset. And of course, because it's going to have a sound, it's going to have an audio resource. It's an audio source, which is going to be the sound called Imp Mixdown 5, which came earlier with a teacher pack for stage 3. For this one, we're going to uncheck Play on Awake and Loop. So, where are you? Not Impact 2, but Imp Mixdown 5. This sound, like a loud thud. I'm going to make sure that this sound is not Play on Awake and not Loop and maximum volume. Now, in this case, we're going to create a script, but the script is not going to be attached to the impact sound because the sound doesn't trigger itself. The sound comes from the car. So first we're going to write the script. So again, in this case, the script is not going to be attached to the game object with a sound, but instead to each one of the track parts. In other words, what I'm saying is, sorry, I said the vehicle. It's not the vehicle. It's the road that makes the sound. First of all, let's write the script. In my scripts folder, we're going to create a new script, a new mono behavior script, and its name is going to be Play Impact. We're going to delete its default content and write this script, which again is not that long. So again, I'm assuming you're going to pause the video, create the script called Play Impact, capital P, capital I, write the code, and unpause the video when your code is written and doesn't report any errors. So here's my Play Impact. And again, I'm not attaching it to impact sound. I'm just writing it. For right now, it's just written in my script. It's just, standalone script. Let's see what it says, assuming that you already typed it. Other than the class play impact, capital P, capital I, to match the name of the file, it's going to have two public fields. One of them is the audio source, in other words, which sound to play. The other one is going to be a floating point number, which is going to be impact min speed. In other words, deciding, okay, when I just drive on the road, I don't hear a thud. It's only when I fall above a certain speed, when my y velocity is higher than a certain number, then I want an audible sound. Otherwise, it'll make like, too many sounds all the time because there's collision all the time. So there's no start and there's no update. There's only an on collision. On collision, enter. And remember, this is going to be attached to the parts of the road. So in other words, the road is asking itself, hey, something collided with me. The object that collided with me, I'm going to give it the nickname or the variable name myPlayer. The first thing I'm going to ask, this is where I checked what the velocity, the y velocity is, because the impact is going to happen from y velocity. Y velocity is, falling down. So the first thing it'll check in the actual code is if it's the player. It did whatever hit me. Is that the object called player? If it is, it's going to check if the current y velocity is bigger than the minimum we're going to set. And we're going to, we can play with that. If it's bigger than the minimum that we have set, then impact sound will play. And that's the end of all those curly brackets. That's the end of the minimum sound, the end of making sure that it's the object with the right tag, end the on collision enter, and end the public class. Before this part of the video is over, let's see how we attach this script. What we need to do is attach this script basically to all the track parts we have already. Any of the track parts we have in whole track, they all need to have this script. So in the hierarchy, we're going to open the whole track as using shift, the shift key, select all of its part, including the straight part, the ramp, the round parts. As shown in the video, attach the script play impact to the inspector so it actually is attached to all the objects that are selected. Let's do that. So I'm going to open whole track. I'm going to select the first track part, hold shift, select all the track parts. Take the script called play impact, drag it to the inspector, and I just attached it to all of them. This has it and this has it. They all have it. I'm still going to make sure that they're all selected, because for all of them I need to populate the two public fields. The first one is like they're saying, okay, we're all track parts, but what sound are we going to play? Impact sound. I can do that either by dragging it in or by browsing for it. It's going to show me that on the scene there's only so many objects that have a sound source, audio source. One of them is impact sound. The other thing I'm going to make sure that I'm assigning for all of them is the impact minimum speed. And going back to the script, what I experimented with is printing the y velocity and showing like, okay, when it falls, let's say when I jump off the ramp, how fast is it hitting? And finding some kind of like a threshold, a minimum that above that speed, I want to hear a thud. But below that speed, it's not, like impact enough to hear sound. And what I came up with is 2 meters per second, just by experimenting. And we can, experiment with it further. So I populated the impact sound, and I'm going to enter 2 for all of them. So they're all selected, and the minimum impact speed is 2 meters per second. So if it's any less than 2 meters per second, it's not going to play a thud. When I play, here's my thud, because it fell down at the speed of more than 2 meters per second. As I drive, it's not really falling down. As I climb the ramp, the Y speed goes up because I'm going up, but it's not going up fast enough. But as I jump off the ramp, it did make a sound. Together with all the sounds. I'm a sound person. To me, those sounds are really important. Just before we're done with this part, I just want to show you that if I made the minimum impact speed, let's say 10, it would barely play or never play any sound, because I don't think I ever go over the speed of 10 meters per second falling down. See, like right now it didn't. On the other hand, if I made the minimum impact speed 0, it would make probably too many sounds. You hear all those? Because every little movement up or down would impact its y velocity and would trigger the sound. So by experimenting, I found that 2 is a pretty good threshold for, an impact that is like significant enough to justify a sound. I'm going to stop this part of the tutorial right now. In the next part of the tutorial, we're going to build some of the rest of the track.